Okay, so since a few more of the students have joined, I'll just reintroduce myself. I am Subhashish Das. I'm currently in the last term of diploma for the electronic systems, and I'll be your TA for the this C programming and all the future C programming sections as well. Keep in mind this is different from an instructor session, so you'll have to attend those sessions as well. So the main purpose of this session is to is for the programming practice and specifically practice for OPPE. So we'll be mainly tackling week 3 to week 6 when it arrives. This class specifically for week 3. If you guys have any questions, feel free to unmute yourself and ask, but do try to refrain from asking while we are solving some problem. Okay?
You are in ES?
Yes, I'm an ES student just like you.
Okay, so you can apply for internship after your diploma level.
Yeah, if you have a good grade, so like A grade or S grade, then you can. We'll handle the miscellaneous doubts at the end of the session. So
Okay.
yeah, I'll just get started with the questions. We'll just get started with the programming like practice questions for week 3. I hope that all of you have solved the week 3 graded programming assignments as well. So you guys should have like some level of idea. But if at any point you find that you need some further guidance or some clarification, feel free to just ask. Okay.
Can you please quick rewind? Because many of us don't know, but they can call sir that they recall.
Um, I mean, I'll just this is a recorded session, so if any of you guys want to see it, then you can see it again. But yeah, I'm Subhashish Das. I'm in the last term of diploma, and I'll just get started. Like I believe that much is enough. I'll be the TA for this
Not
session.
about this video, about C programming. From
Yes.
basics, I
No, no, no.
don't know.
This is for programming practice. So you guys should like. I expect you guys to know some level of programming. Like week 3 is already passed, so you guys should have solved the GRPAs. So yeah, this is mainly for reinforcing the things that you have already learned. Anyways, I'll just get started with this one.
Okay, thank you.
What is the syllabus of OPP 1C?
Uh, Generally, it's from week 1 to week 5, but since week 1 and 2, you guys don't have any programming questions. You can consider it as week 3 to 5. And if you want to like be extra prepared, week 6 also you can prepare, just so that you're not surprised by any like miscommunication at the last minute. Okay, so yeah, can you guys just give me a few minutes? I just have to take care of something. Yeah, sorry about that. So yeah, we'll be just getting started with this one. So this is the week 3. I believe that this is the UI that you all are seeing. So we'll just get started one by one. We'll solve the questions, and I'll try to I'll try to solve everything that we have over here up until PPS 7. So I hope that you guys are able to see this. I'll just increase the font size. Okay. So the first question that we have is complete the program. One second, please. Yeah. Complete the program to calculate the sum of the first n natural numbers. You are given an integer n, calculate the sum of the first n natural numbers and store the result in the integer variable sum. So this is a very simple question. We already have some prefix and suffix code over here. So can anyone
Can
tell
you
me what we have?
please increase size of screen little bit?
The code or the this one? The question.
Screen size.
Okay, just one second. Is it better?
Okay. Now okay.
Yeah. Okay, so we have the question over here. We have to calculate the sum of the first n natural numbers and store it in sum, the variable name sum. And you can see already we have an integer n. We are scanning it and it has already been given. So we have to use n for the integer. And we see here that we are printing sum. So we don't really have any choice in the variable names over here. So can you guys just tell me what we have to do first? Like there are two ways to go about this. Uh, so can anyone of you tell me the solution for this one? It's okay if you don't have the code. You can just tell me any general idea and we'll work on that.
Sir, we can do using that formula.
Which formula can you tell?
Sir, sum of natural numbers.
Okay, and the formula is?
N into n plus 1 by 2.
That is correct. So actually, is it really n into n plus 1 by 2 or is it something else?
No, sir, it is that only.
Okay, so let's just see. Uh, please don't mind the messages. We have, first of all, we need to initiate a sum variable, right? And it's a good idea to, since we are dealing with arithmetic over here, to initialize this to 0, since we'll be adding into this. So there are two ways to do this. First is the simple way. We create a loop and we don't have to think a lot about it. The second is to use a formula. So basically the math way. So I'll just do both of them to show you how it can be done. So first is the math way. So we can just do sum is equal to, what was the formula you told? N into
N into n plus 1 by 2.
n plus 1 by 2. This is correct?
Yes, sir.
Okay, so now I've already written this formula and everything else is already there. I can just hit test run and it should work, right? So I'll just hit test run. And there you go, it does work. So it passed all the test cases and the public test cases are only the private test cases, so you don't have to worry about that. So this is one of the methods to solve this. Can I ask what is the other method to solve this? I'll just do this.
We can use a loop.
Sorry.
Sir, using loops, we can do it.
Okay, so can you just tell me how I can do this? So I've got a for loop. What should the I less than be?
Sir, I less than equals to 5.
Less than equal to. Are you sure it's 5 or is it supposed to be n?
N.
N, sir, n, yeah.
Yeah.
It should be n.
Okay. And then what should we do here? Should we increase or decrease?
Increase.
Increase. Increase.
Okay, so I plus plus, right?
Yes, sir.
Yeah. So now we have a for loop. So what should I do in here?
Sum
there is a
is
lot
equal to sum Sum plus is equal I. to sum plus I.
Sum is equal to sum plus I.
plus I.
Okay. So now it should give us, like, it should run n number of times, and it should add, sorry, it should run n plus 1 number of times if we include 0, and it should give us the correct answer, right? So if we test
Yes.
this,
Yes.
that is correct. So we are getting the correct answer. Now, one thing that I'd like to suggest over here is that whenever we are writing something like sum equals sum plus, so we can just eliminate this part and simply do plus equals. So this is basically like a shorthand to show the same thing. So now if we just do this one, yeah, so you can see it still works. So that is the first one. So both of these are working perfectly fine. So you can just, you know, so that was the first question. Now to move on to the second question, I'll just submit this one. Okay. Now let's move on to the second question. Okay, so this is for simple interest. So over here we are given simple principal, rate and time as double values. Can anyone tell me what double values are?
Yes, sir. Long,
Okay, please go
double
ahead.
value is a double value is nothing but a long float.
Right. So it's basically like a double precision value float.
LF LF is a format specifier for this.
Right. So it's basically like a double precision float value. So what we can do over here is we already have the variable names. So we don't really have any choice with the variable names. Simple interest also we are given here. And we have a formula over here. So this is a simple case of writing the formula and doing it. So notice that we don't have any simple interest over here. So we have to put this here. And from the output, we can see that simple interest is also supposed to be a double. Okay, so what we can do, double simple interest equals, we have the principal into rate into time, all divided by 100, right? I mean, I guess this is a very simple thing, so I can just directly enter. Yeah. So there was really anything to do in the second one. Did Is there any doubt in the second one?
No, sir.
Everyone else?
No.
No, sir.
No.
Okay. So I'll just do one thing.
Sir, if you will discuss these for week 4, that will be good for us.
Yeah, I'll do that. So, like, can you all just tell me if you guys are all comfortable with, if you all are comfortable with this one, like week 3, like variables, operators, and stuff like that.
Yeah, it's okay.
Yes, sir.
Okay, so everyone is good with that, right?
Yes, sir.
Okay, so I'll just move on to this one. I've already solved these. Okay, so let's just do this one. Okay, so let's do one thing. I have my uh, Visual C, uh, Visual Studio Code over here. I'll just create a new one. Okay. don't know why this is like this. Okay, no issues. I'll just
Sir, you
take
can
this.
also use online compiler such as programming or
Yeah, it's
GDB.
fine. It's fine. I'll just get rid of all this and test run this to save it. Okay. So basically, the first question is that we have to, you know, we'll have to write a program that accepts an integer n and gives us a factorial, the factorial of n. So what we can do over here, sorry. Okay, so can you guys just tell me what to do? I'll just
Sir,
tell
we can
the,
use a for loop.
we can use a for loop, right? So
Yes, sir.
what should I put here, like in the boilerplate code?
Sir, std
Okay. So I guess everyone is aware of the like boilerplate code and what we have to do in order to get this to work, right? So int main,
Main void main
yeah.
0.
So firstly, what do we have to do?
We have to assign a variable.
Right, we need an int n, right?
Yes, sir.
Now tell me,
Which we have to
will
take the
something
input.
happen if I don't put equals 0 over here?
And stores a garbage value.
Yeah, and stores a garbage value. But is that necessary in this situation?
No, sir. We should take n as a user
Input
input.
from users.
Right. So I can just do scan f, and then I'll take percentage d and at the address of n. Okay. One thing I want you guys to note right now is that this and, it is essentially denoting that we want the address of the variable n. Okay, so where n is stored, we want to update that value. It is not it is not necessary to be fully aware of right now. So just it's okay. Yeah, so this is, we have gotten the value from the user. So now what should I do? What should we do?
We should construct a loop.
For
Okay,
loop
so int I equals 0.
and initialize the value of I is equal to 0.
Okay, so what do we have to do?
N
Less than equal to n.
Less than equal to n, are you telling? Okay, so I plus plus.
plus.
Okay, so that is the for loop. Now what should I do?
First, we have to assign a variable for factorial.
Okay, so I'll assign
Equal to
another
0.
variable over here. Int fact equals. Now what should I put over here?
1.
So one.
1 or 2.
Okay,
We
so
can use 2 also.
1 or 2. I'll come to that later. But
Yes.
why are we using 1?
Because it's print by starts from 1. Suppose the factorial of 5 will be 5 into 4 into 3 into 2 into and last one it will breaks. It will stops.
Okay, so why can't we put like something 0 or some garbage value over here?
If we put 0, it all multiplied by 0 and give us the value 0
It's
in
the
result.
output of 0.
Okay, so okay, you guys are correct. So the reason we put 1 over here is because if we were to put 0, then that 0 would cancel out everything else and it would end up as 0. So 1 is essentially like the, you can multiply anything with 1 and it will give you that same number. So we are using 1 over here. So
Sir, we can do we can do here 2 also, because anything multiplied by 1, the same number comes.
okay, we'll try that after this. Okay.
Okay, sir.
So factorial what do I have to do over here?
Multiply equals to I.
Okay, multiply equals I. Is that it?
Yes, sir.
Yes, sir.
Okay, so now all I have to do is print the value uh, percentage D fact.
So print F.
printf होगा.
Good. So this should work, right?
Yes, sir.
Yes, sir.
Okay, so let's just test it. And I'm predicting that this will not work.
Because you described int in the for loop.
No, that is not the actual reason. Just
Sir,
one
in
second.
for loop, I should be equal to 1.
Exactly, yes. Um, you are Shamita, yeah.
Yes,
So
sir.
yes, that is correct. The reason that it won't work in that case is because we initiated the for loop with 1. Okay, this is showing very weird behavior. I'll just have to. Yeah, sorry about that. I just accidentally quit the program. Uh, yeah, so as I was saying, I hope my screen is visible.
Yeah, it is
Yes, sir.
visible.
Yeah. So as Shweta just told, the reason that it did not work. So PPA tree, right? Yeah. The reason it did not work over here. Let's see. Okay, no,
Week 4.
yeah. So this one we were doing. Okay. So the reason that this did not work is because we initiated it with 0. So essentially, what was happening with the test cases was that we were getting 0 into 1 into 2 into 3 into 4 and so on. That initial 0 basically multiplied everything else into 0. So what we have to do over here is multiply this by 1. Is there anything else that needs to change in this program? Anyone? So is anyone able to find anything that needed to be changed in this program? If not, then we'll just take a test run, okay? Are you guys able to hear me? Like just a quick mic check.
Yes, sir.
Yes, sir.
Okay, okay. Okay, so let's just test run this.
I think
Yeah, and see, it passed all the cases. Okay, so now, as someone was saying before, uh, uh, I guess, could you please tell what you were saying again?
no, sir. I am saying that this will work.
Yeah.
Nothing will be changed.
Okay, good. So, one of the doubts earlier was that what would happen if, like, we could put 2 here also, right? So,
Yes, sir. Yes, sir. We can put it.
okay, so let's just test it out and see what happens.
Same result will be.
Yeah, let's see. And you are seeing that there's an extra 2 in the multiple, right?
Yes, sir.
So What you are saying is correct. The only thing is that this number, it will no longer be 1. If we put 3 here, then it will be correct. Can anyone tell me why?
The loop starts from 2 into 3 and then so on.
Right. So before, when we were starting from 1, it was going 2. So factorial was already 2. So it was going 2 into 1 into 2 again. So there's an extra 2 in the factor. So can anyone tell me why I cannot start it with 2 like this?
If we put 2 here also, then we get 2 into 2, 4 for starting well.
Right. So that's why we have to put 3 here like this in order to get this to work properly. Is that clear?
Yes, sir.
Yes, sir.
Okay. So anyone has any doubts?
No, sir.
Okay. So I'll move on to the next question. Okay. So the program here, like the question over here, write a program to check if a given year is a leap year or not. Accept an integer value of y as input and print y is a leap year if y is a leap year, otherwise y is not a leap year. Okay, so before we get started with even the boilerplate code, could anyone tell me what is a leap year?
Uh, Actually, a leap year as contains
In a February, there are 28 days and 29 days.
yes, in leap year
Okay,
it consists of 29 days.
okay. So can you guys just tell me uh, how often does a leap year occur? Like when does a leap year occur?
In every
A
4
leap
years.
year
Yeah,
occurs 4 years after 4 years.
Are you sure? Like every 4 years?
Yeah, I think
Sir,
it occurs at every 4 years.
Okay, so can you tell me if the year 2000 was a leap year?
Oh, yes, sir.
2000 was a leap year, right? Okay, so
Yes, sir.
was the year 1900 a leap year?
1900? No, sir. I think no.
1900 is divisible by 4, right?
It's divisible by 4, but it's also divisible by 100.
So that's the full condition that we need. If
Yes,
for an for a year to be a leap year, it has to be like it has to be divisible by 4. So a leap year occurs every 400. But if the year is divisible by 100, then we'll have to check if it is also divisible by 400. Like in the examples given, the le- the year 1900 was not a leap year because even though it was divisible by 4 and it was divisible by 100, it was not divisible by 400, right? So that is why 1900 is not a leap year, but the year 2000 is a leap year. So
yes, sir.
is that understood, or um, uh, do you guys want me to repeat?
Uh, I think it has two cases. One of them is the number that should be divided by 4 and not 100. And another case is the number divided by 400.
Okay, we'll just take a look at the code. Has everyone understood the like how often a leap year occurs, like the condition behind a leap year?
Yes, sir.
Okay, so let's just get started with the boilerplate code. Okay. So I'll just get some of the trivial stuff out of the way. This I hope that you all will be able to figure out even without me explaining what every step does.
Yes, sir.
Okay. So now this is where we have to start. So this is the code, like this is the place where the code will go. So can you guys just tell me what I have to do first?
We can use a if-else statement. Do
Yeah.
this.
Like see, over here, this is one spot where we have multiple methods to check. Okay. We can use an if-else
Sir,
conditional. Yes.
sir, we can use ternary operator also.
Ternary operator is essentially an if-else statement only, right?
Yeah, sir. Both
Yeah.
are
So
different.
I mean, both of them function exactly the same.
Yeah,
Like
yeah.
the end
Yes,
result is
sir.
the exact same. So yeah.
Yes, sir. Yes.
Anyway, you can use an if then else statement. You can use a ternary operator. So, like right now, I just want to keep it simple so that most of the maximum students can understand it. So I'll just use an if else then loop, conditional statements. So what should a conditional be for the first one?
It should divisible by 4 first.
Suppose we take a input y, and it is
Okay.
modulo with 4,
Modulo with 4.
4, as well as we put a and operator between.
Okay, so we modulo it with 4. So what should we get?
We get a number
Sir, it must be divided.
by 4. That we get the remainder after division, after divided by 4.
Okay, now see. So we want
It should equal to 0.
equal to 0 or like
Double
single
equal
or
to,
double?
sir. Check.
Double equal
Okay.
to
Check.
Double equals to, sir.
Okay. So
For
after
check
this,
condition.
okay. So that is essentially checking if the year is divisible by 4. So what do we have to do next?
We should
we
also
have to
check.
put an and operator. And
Okay.
operator and the next y modulo
Y modulo
100 should not equal to 0.
should not equal to 0. Okay.
Yes.
And next,
And next another conditions that will be uh, the number which is divisible by 400, and we
Sir,
can
it should be
use
divisible
or
by 400.
yes, sir. Or we can use a or
so
operator with 2 cases.
okay. So can you just tell me like how to write this?
Yes, sir.
Sir, now by using OR operator.
Like this.
No, sir. After bracket.
See,
After bracket,
see
we
that's
put
part of the
operator.
thing, right? See, the thing is, we have to like keep the code neat and simple so that someone else can understand it and they can work on it. Or even a few months from now, when you look back at the code, you should be able to understand it, right? So if we program like this, then there's a high chance that we'll forget what the code even does, right? And it will be tough to recall and understand how we came to the conclusion of what we did or how we solved what problem was occurring. So what I recommend is this part is okay, right? This part is more than sufficient to check if the year is divisible by 4. After that,
Okay.
there are multiple cases, right? So we'll just do the simple thing first. We can put an else. If it is divisible by 4, it's possibly a leap year. But if it's not, then we can just printf percentage d is not a leap year, correct? And percentage d is just year. So this part, did everyone understand?
Yes.
Okay, so we have the simplest case finished, right? So now we can go deeper into this. So now we have the case of whether year is divisible by 100.
Sir, I think we should write all if statement in just one line. That will be easy for all, I think.
Will that be readable?
Ye- Yeah, why not, sir?
Okay, so can you just tell me how to do it? Like, I'll just finish this one first. This is a simpler approach.
Okay, sir, okay.
So, yeah. So, if it is divisible by 100, then we'll have to check again, right? If it is divisible by 400 or not. If it is divisible by 100, uh, like if it is not divisible by 100, then what do you know? So, like it is divisible by 4, but not divisible by 100. So, is it a leap year or is it not a leap year?
Leap year, sir.
It is a leap year, right?
Yes, sir.
Yes, sir.
Okay. So, that is another simple case that is solved. After that, we can just go one step deeper into the final level. Y modulo 400 equals 0. Okay. So now, if the year is divisible by 400, then what do we know?
It will be leap year.
Is it a leap year or is it not a leap year?
It
It will be leap year, right? Okay, we'll input that
Yes, sir.
into the code later.
is leap.
So it will be a leap year, right? And now we just have one final else code, and we'll print here P is not leap year. Okay, so this looks good. Shall we try running? Okay, so let's just run this one. And as you can see, it works perfectly. So this is the simple solution. Like you can see each step what it does, and you can reason through it uh, relatively easily. Okay, so now let's just comment this out and write the one that you guys have written. Yeah. Okay, see this. Okay, so this will have a syntax issue. Okay, so see, we are saying that y is divisible by 4 and it is not divisible by 100. That part is okay. But that is where the conditional bracket ends. Okay, so if we were to do it like this, we'll run into some error. So I'll just play it like a dummy code or something.
Sir, I only
Print
write
that.
logic.
Okay, we'll just fix it later. But yeah, it will give us see, it gave us an error. So what we can just do over here is format it properly. And now that we have a couple of brackets in place, this is a single condition. And we are checking whether it is divisible by 4 and it is not divisible by 100, or it is divisible by 400. So now If it is that, then what should we do?
It will be leap year.
If the condition is true, it is leap year. So
Yes.
like this. And then we have an else condition. And it is the not leap year condition. Correct? So you guys understand this, right? I'll explain this step by step in a bit, but it should work like this. Okay, seems like there's some other issue.
Sir, it must be capital Y, sir, because we have undeclared
Okay,
it.
yeah. Okay, so now it should work. Yeah, it works perfectly fine. So what we are doing over here is pretty much the same thing as over here, just condensed into this one. So first we are checking, like I'll just go how the compiler checks. First we are checking whether it is divisible by 4 or not. If it is not, it will directly print it is not a leap year. If it is divisible by 4, then it will now check whether it is divisible by 100. If it is not, then it will print it is a leap year. If it is divisible, then it will just go into this OR condition. And in the OR condition, it will see 400, like if it is divisible by 400. If it is true, it will straight go to this one. If it is not true, it will go to this one. Is that much clear?
Yes, sir.
The others?
Yes, sir.
Okay, then. So I'll just move on. Yeah. Does anyone want to say anything? Okay, then I'll just move on to the next one. If you have any doubt, then please do ask. So we are at this PPA2. So we are going to PPA3. Okay. So we just have a function over here. So can you guys just tell me how? Okay, so here's a task for you guys. This question I want you guys to solve using switch case conditional statement. So how can we do that? I am audible, right?
Yes, sir.
Yes, sir.
Okay. So this is the question. We have to write down this program into here. We have to write down this function into a program. And I want you guys to essentially tell me how can we do this using a switch case statement.
Which defines a certain roles.
Sorry?
Sir, we will use a switch case statement. Firstly, we take our inputs from the users.
Yeah, so I'll just write down that code. So we want an input of X and output with 2 place decimals. Okay. So scanf percentage f comma and x. Okay, so you guys now have an x. So how can we move forward with this?
Right switch.
Okay, switch. And what's the condition over here?
Yes, sir. X. Put X.
X.
Yeah. And give the cases. Yes.
Okay.
Case
So
1.
case
1.
1.
If X is greater than and less than 10.
Okay, see, in cases you have to write down the actual case. So right now it is, what do you call? Right now this is x, so it will return whatever value it has,
Yes, sir.
right? So we have to add a conditional in this one to make sure that it gives us like the value that we want.
Okay, sir.
So how can we do that?
Sir, I didn't get you. Could you please repeat?
Do you want me to repeat it in Hindi?
Yes, sir.
हाँ, तो हम यहाँ पे क्या कर रहे हैं, यहाँ पे हमारे पास x है, तो ये x एक कंडीशनल है, ठीक है ना? तो इसका जो भी वैल्यू निकलता है वो हम चेक करेंगे. अगर हम नॉर्मल एक x यहाँ पे डाल दिए और मान लेते कि यहाँ पे हमारा x का वैल्यू है 5, तो फिर यहाँ पे 5 जाएगा. अगर हमारा x का वैल्यू है 100, तो यहाँ पे 100 जाएगा. और हम 100 केसेस तो लिख नहीं सकते हैं ना, तो हमें कुछ एक तरकीब यहाँ पे लगाना पड़ेगा. Did the others understand that as well?
Yes, sir.
Okay. So the normal case is okay, right? So normally you guys can solve it easily. Okay, so can you just tell me how to do it normally? We can get back to this a bit later when we have enough time.
We can use if else.
Yeah. So if, what's the condition over here?
If X is greater than and less than 10.
We
Greater
cannot.
Greater
We'll
than
have to
zero.
use an and over there. Tell me something like, how can you do this easily? Like I want only two cases in this one. So if, else if, and else. I want it like that. I don't want any and, I don't want any or. So can you just figure out how to do this?
Actually, I have no idea.
Okay, that's not an issue. Others?
Sir, you can put float x equals to 0, and in downwards if statement you can do that x is less than 10.
X is less than 10.
Yes, sir. And now it will the printf statement will give x plus 2.
Are you sure about that? Let's say
Sir,
that the value given is minus 10. That will still satisfy this, right? But we want 0 when it is minus 10. So keep thinking. It's good that you're thinking, but yeah, it's very close.
We have to use a bitwise operator.
That won't be necessary. Like honestly, bitwise operators are quite complex. Even for I don't really want to use bitwise operators, even for embedded C and stuff. So it's better if you guys avoid bitwise operators in this one.
Okay. Sir, it's already a easy method by using a if else.
Yeah, it's easy enough. So I want you guys to just think how to optimize it even further.
Sir, can you please give hint?
Okay, so what are the extreme values in this case?
10.
And
10 and 0, sir.
10 and 0, right?
Yes,
Yes,
sir.
sir.
So I have two extreme values. So how can I make it so that uh, we get a desirable result in two conditions?
Sir, we can use that nested loop.
Not necessary. It is
Uh,
just one condition, like two conditions.
yes, sir. Actually, the first says that x is greater than 0, but it is less than 10. And the
Yeah,
second one says that x is less than and equal to 10. So
yeah.
we can merge them into a single function.
Can we? Okay, so see, this is a typo. I hope that you guys recognize that. Actually, no. Yeah, no, this is not a typo. This is x is greater than equal to 10, not less than 10.
Yes, sir, it is correct.
X is
Yeah,
greater than, yes, sir.
yeah.
Greater
So
than
x is
equal
greater
to.
than equal to 10. And we have otherwise over here, we have x is greater than 0, greater and less than 10. Okay, one more hint I'll give. You don't have to follow this order. Okay, you don't have to follow this order in your code. Like in the or in this function, it is given x plus 2, this one first, then x square plus 2, this one next, and 0 next. You don't have to follow that one. You can do 0 first, x plus 2 second, x square plus 2 third, whatever. That's up to you. So use that hint and tell me what we can do. I'll just show the screen. Yeah.
So we
Anyone
simply
is able
take
to?
as x greater than 10 and greater than or equal to 10,
Okay, so x greater than equal to 10.
and then we write the
Yeah,
our
so
result x is equal to
print
x plus
f
2.
percentage d, comma, and we want x times x plus 2, correct?
2 exactly. And else,
Else,
if x is
if
less than
x
10,
is less than 10.
yep, then the result printf
Okay, printf.
percentage d x plus 2. Else printf x.
Okay, and finally there's an x, printf 0. Is this what you're telling?
Yeah, not 0, but maybe x, because x initial value is 0. So it will come 0, I guess.
No, no. See, it is
Huh?
if it is
Yes.
minus 10,
Okay.
then also it will print. So it is supposed to
Yes,
be
yes,
0.
yes.
See, this is correct. Okay, but this is not optimized.
Okay.
And one more issue over here is that you will never reach 0.
Yes, sir. Because Below 10, sir, negative number can also occur, sir.
Right. So that
Yes,
way,
yes.
never enter this one. I mean, you're on the right track. It is going to look something like this only. Now we have to figure out what that something is.
We have to put
Maybe
another condition in else if.
It's not necessary. You don't need another condition. You can modify one of these two to get it to be correct.
we can start reverse, like if x is greater than 0, and then second is if x is greater than or equal to 10.
It's not
And
necessary.
no,
See,
okay.
you guys have studied this like inequalities, right, in maths.
Yes, sir.
So what do we do when we have like multiple inequalities and we have to find the answer?
Where we go?
For example, x minus 1 into whole into x minus 2 is less than 2.
Sir,
So where we go?
Weaver method.
Baby
Wavy
curve
curve
method.
method, right?
Yes, sir.
Okay, so think of it in a similar way over here. You have two critical points, 0 and 10. So what will you do?
The first case will be the below 0, and second will be between 0 and 10, and third will be after 10.
Okay, so let's say that I want greater than that one. So it depends on whether we want greater than less than, right?
Yes.
So if it is like greater than 0, then we want the positive ones. If it's less than 0, then we want the negative ones. Let's say that I want the greater than condition in this case.
Sir, else if x greater than 0, it might work.
Else if x greater than 0.
Because x greater than equal to 10 already satisfy the second condition.
Right.
So it will never reach there.
Okay, so this is correct. Good job on this. This is correct. I guess I missed something over here. Yeah, this is supposed to be dot f, not dot d. My mistake. Uh, 0.00, yeah, sorry. Yeah, this formatting is really a headache. Okay, but yeah, that is correct. We are getting all the correct cases. Now, there's one more way to do this.
Sir, you have told that you have not used a else if, and you
No,
have
no,
used
I told I don't want to use the logic conditionals. So like,
uh,
and I don't want to use, or I don't want to use.
you have said that only use a if a statement for one times.
I want two conditions, I told.
Yes, sir. One is if, and other will be else.
No, no, two conditions. Else is not a conditional. It is like there's no condition for this. This is one conditional, and if it is not executed, it will go to the second conditional. If this is not executed, then it will print this one. It does not require a conditional. Okay, I guess there was a bit of miscommunication, so I apologize on that part. But yeah, this is correct. But there's one more solution, and that involves this. So can you tell me how this will work?
Uh, for whole code, sir.
Sorry?
Uh, you are you want to know the explanation for whole code.
No. I just changed this from greater than to less than.
So
So
how this will work?
that is what I'm asking. What other
Hmm.
changes has to be made in the code for this
Okay,
to work?
what other changes to be made? I think then mm,
Sir, if x is
Yes,
less
sir.
than 0, then sir, negative numbers will come.
Yeah.
The
So
last else statement will print 10. Get. Yes, sir.
this would be yes. Okay.
yeah. So
Correct.
Yes.
it should work like this, right?
Hmm.
Yes, sir.
Correct. You're right, sir.
Uh,
Um,
okay, so we are getting this one. Why are we getting this one? Because this is supposed to be less than equal to. Now that fixed it. So yeah, just multiple different ways to solve the same problem. It always helps to have a broad mind in order to approach these questions. This is a simple question, I admit, but yeah. The switch case one, think of it as like some activity question that you can do on your own to figure out like the depths of this one. You don't have to focus too much on this. This was only like to test this one. If you want, you can continue working on this one. I'll just move on to PPA 4. Anyone has any doubts in this other than the switch case one?
No, sir.
Everyone else?
It is clear, sir.
Okay. So I'll just move on to the next one. PPA 4. Okay, so this one is a bit like there are two solutions to this question. There's like easy solution, so the simple solution, and there's a math solution to this also. And the math solution is very efficient. So I encourage you to try to figure out the math solution. So even though it is a tech startup, each employee at the startup is given an employee ID, which is a unique positive integer. On one warm Sunday evening, 5 employees of the company come together for a meeting and sit at a circular table. Okay, so we have a circular like grid like this, a circular graph. You guys may have seen this in PNC or permutation combination like diagrams.
Yes, sir.
So the employees follow a strange convention. They will continue the meeting only if the following condition is satisfied. The sum of employee IDs of every pair of adjacent employees at the table must be an even number. They are so lazy that okay, so the rest is just what is it called random story, so you don't have to focus on that one. This is important. E1 through E5 is their ID. Now notice that we are not given any like boilerplate code or prefix suffix, so you're free to use any variable you want. A, B, C, D, E, if you want, you can use that. Anything you can do. Just the output should be either yes or no. There's no other option for this one. So I'll just write the boilerplate code. Till then, you just think, I want only the math solution for this. I don't want a simple solution. Okay. So I'll just explain the simple solution right away. You can check. So E1 plus E2, you can check, add and then modulo to see if it is divisible by 2. E2, E3, you can add, divide modulo by 2 to see if it is divisible by 2. Like that only you can do 5 different combinations, and that is the simple solution. Like that is the easiest thing that anyone can come up with. It will take a long time to implement. So I want you to figure out the math solution. There's one property that will make this super simple. Okay, so this is the boilerplate code done. I just need a condition over here. So have you guys figured out what to do yet?
We have to use a modulo and checks every that is it is divisible by 2 or not.
Okay, I'll just do this everything in here. E1 module 2, E2 modulo 2, E3 modulo 2, E4 modulo 2, and E5 modulo 2. Okay, so I moduloed everything. So what do we have to do now?
E1 modulo 2 is equal to 0.
Are we checking if each of them is even?
Yeah.
Okay.
We have used a and bitwise operator between them. If
As I
all
said
are
before,
even, if all are even, it's print yes. Otherwise, it prints no.
are you sure that everything being even is the only condition in which this is satisfied?
I think if everything is odd, also it will satisfy.
Yeah.
Yes, sir. Yes, sir.
But it should be either all even or all odd.
Right. So how can we show that?
Okay. Yeah, I think all even means this all modulo should be 0. E1, E2, E3, E4, E5.
Right.
And for odd, we can say
All modulo will be not equal to 0.
Yes, sir. It
Yeah.
will
So
not
what will
equal
it
to 0.
return?
Then also, sir, it will return yes.
No.
If
What will it return? Like E1 modulo 2, if it is not even, what will it return? Like 3
If
is not even, right? And 3 modulo 2, what will it return?
1.
1. So if there's any number that is not even and we modulo it, it will give us 1, right?
yes,
Yeah.
sir.
Yeah. So this is the trick that I wanted you guys to figure out. What will happen if I do this?
okay, this will be an even number or an odd number.
So what are the two possibilities that we'll get from this?
One of them is the sum of all 5 will be 0,
And the other?
and the other will be the sum of all will be 5.
Right. So is there any other thing that can come in between? Like, is there any other possibility?
No, sir, no.
No, right? So
Yes, sir.
I can just take this, stick it over here before this, right?
Okay.
And I can just store this in, let's say, E1. So E1 will have this value. And this modulo 2, I don't have to do all this many times. I can just add everything up.
Yes, sir. And
And
modulo 2.
yeah, all at once I can modulo it.
Yes, sir.
So now we have this value stored in E1, which is either 0 or either 5. So what do we have to do over here?
E1 should be either 0 or either 5.
So this is essentially what you are telling me,
Yes, sir.
right?
Yes, sir.
So let's just test it out. Okay, so we have an issue over here. It is telling 1, 3, 4, 6, 8. So everything, okay, so these both are odd and these are even. So it should not be like this, yet it is telling yes. So what can be the issue?
Uh,
Sir, for this question, I think there are only two conditions. First of all, the first thing, every employee should be in, yeah, all in even or in odd, but not in both.
Sir, even should is equal to 0, as well as either even is equal to 1.
See. The thing is, this is actually a trap. Like I set you guys up because we cannot do this.
Yeah, we have to check every
Exactly.
particular seat that is even or
Exactly.
odd.
So this one was correct from the start. I mean, I was hoping that you
Yes,
guys
sir.
would fall for it, but yeah, you guys learned, right? So yeah, that is what matters. So here we can just do E1 equals 0 or E1
Same.
equals 5. So now can you guys tell me why it did not work?
Uh, this code will not work.
No, this code will work.
Yes, sir.
Like I can just run this and it will work perfectly fine.
Yes,
But
sir.
my question is, why did the other one not work? Like why did it not work when I added everything and then took the modulo?
Because there could be condition when some of the code would be even and then still we will get.
Honestly,
Sir.
yeah, like see, this is where it went wrong, right? Case 3. So do you notice something from here? It is extremely simple, don't worry about it.
So why are you writing 5 here? I don't know.
Yeah, see, the thing is, we are adding the modulo, right?
Yeah. Yes.
So can you just tell me what will happen if this is odd? Even is odd.
Uh,
It
even or
will
odd. If
okay.
it will be 0, then it will be even.
Yeah, and
If
if
it
it
will
is
be
odd,
not 0, then it will be odd.
so what value will this give? If the value of E1 is odd,
Yeah.
let's say something like 1, like it is given over here. Let's say that E1 is 1.
It gives
So what will
1.
be written over here?
0.5.
So 1.
Yeah, 1.
Yeah. So it will be 1. Remember, this is modulo. This is not division. So yeah, it will return 1. So if it is odd, it will return 1. And as you guys said before, either everything has to be even or everything has to be odd. Those two are the only solutions to this problem. So if E1, E2, E3, E4, and E5 are all even, then we should be expecting 0 on everything, right? Now tell me what happens if everything is odd.
It
It
gives
gives
That will be okay, sir. That will satisfy the condition.
Right. Everyone will give 1 as um, an odd number moduloed by 2. So we have 1 plus 1 plus 1 plus 1 plus 1, so 5. So in the end, the conditions that satisfy our need is either 0 or 5. And we can be sure that 5 is only possible when there's all odd, because if even one of these is even, we'll get 4, 3, something like that. And in that case, it will print out no. Is that clear?
Yes, sir.
Yes, sir. Clear.
Okay. Krishna, you want to ask something?
So actually, you did whatever I don't understand, but I have do this question in a different way. May I show you the solution? Did I have
Uh, sure. Like, did you like add the adjacent pairs and then modulo those?
yes, sir, I have done in this way.
Yeah. So that was what I was saying. That is the easy method, or I guess the simple method would be more accurate, where you don't really have to think too hard to solve a question, but it will take a bit longer to implement. Like,
Oh,
I believe you had to write 5 cases, right?
yes, sir.
Yeah, that's okay. That is also correct. So don't worry about it. Yeah.
Okay, sir. Thank you.
Yeah. So back to my original question. Why did this fail when we tried to take the total sum and then modulo it?
Yes, sir, I know that when we take our when we add our together, and after that we have to take a modulo, then it does not mean that uh, it is even. It does not mean that every value will be even or odd.
Okay, so can you tell me what happened in this specific case?
Yes, sir. Suppose E1 will be 1, E2 will be 3, and E3 will be 4, and 6, 8. After adding these, it gives up uh, 22. Okay, and 22 is even number, but still you can see that not every E1 E2 will be even.
Correct. Yeah. So that is like what is happening in the computer level. Uh, but the simple thing that you can see over here is pretend that these both are added together. Like these both are the odd ones out, right? Literally. So just add the odd ones out. So you get 4, 4, 6, 8, right? So instead of having 5 numbers, it's like you're having 4 even numbers,
Yeah, yeah.
right? So yeah, we have 4 even numbers over here, and that's why it was printing yes, because it was treating these 5 numbers as 4 even numbers. And similar case over here, we have 3, 5, 7, 8, 9. So 8 is even, the rest 4 are odd. So as you know, if you add odd and odd, you'll get even. So do that twice, you'll get even only. So that's why it treated this also as an even. And finally, This one, yeah, this is completely odd. Okay, but if you add this, you'll get a leftover one. Okay, so if we just add this, we will get like 8, 17, 30, 51.
It will be odd.
Yeah, 51 is odd, and upon modulo, it will return 1, which is not either of these. So it will print no. So that was what was happening. I hope you guys understood the logic behind it.
Yes, sir. Yes, sir.
Okay, any doubts?
Sir, we can use any number in this place, sir. Even equals to 5. We can use any other number than 0.
See, the thing is, we have 5 inputs over here, right?
Yes, sir.
So the maximum number that we can get is 5. It can be less than 5, but it cannot go over 5. Similarly,
Yes.
the minimum number that we can get is 0. Right? So it can go, it can be anything more than 0, like up to 5, but it cannot be anything less than 0. So we have a set range where we can get the output, and we only want the extremes of the output, right? Because we either want all evens or all odds. So that is what we are doing over here. So let's just say that we had like 7 variables. In that case, you could change this to 7. Or if we had like 3 variables instead of 5, you could change this to 3. So the choice is really up to you.
Sir, we can any lesser number than 5. We can do that.
See, the issue with that is that after that, permutation and combination start getting involved, right? So we don't know how many of these people are, even or odd. And if we get 4, it could be like these 4 are even, this guy is odd. Sorry, these 4 are even, this guy is, sorry, E1, E2, E3, and E4 are odd, and E5 is even, or E4 is even, or E3, E2, E1. Any one of these can be even. So that
Yes,
is not really helping us.
Yes, sir. It's become very complex.
Yeah,
yes, sir. So we take in 5 so that all can come.
yeah, exactly.
Okay, sir. Clear.
Yeah. Now, if the question was like, instead of every single adjacent being even, if we were allowed to make one mistake, okay, in that case, it would, over here, one more condition would come, or E1 equals 4. So this additional condition would come if we were allowed to make one mistake. Like, but that goes into permutation and combinations. So I won't touch upon that here. Okay. Any other doubts?
No, sir.
Okay. So I'll just move on to the practice programming assignment 5. Two integers are only co-prime if the only common divisor between the two integers is 1.
Yes, sir.
Okay, so actually let's just see what other questions we have, since we only have like 35 minutes left. So we'll just solve the interesting ones. Okay, this is compound interest, and this is basically discount. Okay, so everything that we have right here is quite like simple. Only like this one, you'd have to know that there's a mat.h library, and you should use that one. And it is
For power function.
For power function, sir, we are using that.
exactly. So I've just written it here. I won't bother deleting it. Like you guys have seen it so far, right? How it works. So it's basically like this. And yeah, like one thing over here that you had to keep in mind, the rate is given in percentage over here,
Yes, sir. We have to divide by 100.
right, to get the decimal value of the rate. So yeah, this program is quite simple. uh, I actually have a couple of other programs that I have written down,
Sir,
not in Visual Studio.
sir, actually, I have to practice more questions regarding OPP visa.
Yeah, I understand. This is related to the OPP only.
Okay,
Like
sir.
these are PYQs, you can say. Not exactly like PYQs, but these are previous questions that will help you in OPP.
Okay,
So,
sir.
like,
Sir, the OPP exam will be till sir week 6 content or week 5 content.
uh, better practice till week 6. Like, I I have to make sure if it is till week 6 or week 5. But yeah, just to be safe, just practice till week 6. From what I remember, week 6 is not even that like. Just one second. Yeah, from what I remember, week 6 is not really all that tough. Like, okay, no. Week 6 is where you get started with pointers.
Pointers, yes, sir.
Pointers, recursion, and so on.
Not recursions necessarily, but you get started with pointers and arrays. Uh,
Yes, sir.
yeah, no, it will be fine. Like, mostly practice for up to week 5, okay, and dedicate some time for week 6.
Okay, sir.
Okay, because you will have to practice pointers quite a bit before understanding them. I'll still conduct sessions before OPP, so you don't have to worry. But yeah, once week 6 starts, I'll just hold some sessions for pointers dedicatedly. Okay, for now, Joe, for now, just focus on these questions. So I'll just, where's this one? Okay, so I'll just put these in the chat one by one. Or I'll just make a Google Doc and send it out. If it does not fit,
Actually,
okay, it does not fit.
upload in your Google Drive and send the link of that drive.
Yeah, that would be better, wouldn't it?
Yes, sir.
Okay. So here's the link. You guys can practice this at your own time. Yeah, so we have a few questions. So first question, you are developing a program for a car rental agency. The given C program, complete a given C program by creating the function calculate a rental cost, and that calculates and returns the rental cost for a customer based on the number of days and the type of car rented. Okay, so I guess this is like week 5 content. Yeah, that is week 5 content. So you'll just have to, brush up on that one. But yeah, these are good questions. And even if you don't have like a calculate rental cost function, you can still make it without the function, right? Within the main code itself.
Yes, sir. We can do that.
Yeah. So just consider this as some extra work. Question 4, I was in the middle of giving. No issues. I'll just update this soon. Yeah, I'll just open a Replit to test those ones.
Sir, actually, when I am using a Replit,
Yeah.
it is not of free persons.
It is not free, you're telling.
Yes, sir.
I mean, yeah, it's not free. Like you can only have a maximum of what 3 ripples. So within those 3, what you can do, it you have to do. Okay.
Simply deleting the previous one.
Yeah, you can delete the previous ones to make room for a new one. That is completely fine.
Okay, sir. Okay.
Okay, so question 1, let's just do. Or okay, no, question 1 is way too simple. I'll just go to like question 3. Okay, no, that one requires that one. Question 2 only, let's do. Create a function, print. Okay, I should have read the questions before doing this. Okay, question 3 only. Question 1, let's do. You're developing a program for car rental agency. Complete the given C program by creating the function calculate rental cost that calculates and returns the rental cost for a customer based on the number of days and the type of car rented. The function takes 2 integers, the number of days and the car type, 1 for economy, 2 for standard, and 3 for luxury, as inputs, and returns the total rental cost as integer value using following charges per day. And these are the charges. Okay, so let's just start with the boilerplate code. Okay, so int car.
Sir, we can also solve this by using a simple logic.
Okay, tell me.
Uh, Simply assign the variables, that is number of days and the types of car.
Yeah.
And yes, sir. And after uh, we have used a calculation simple. Okay, sir. I am giving you a code in the chat box.
Okay, fine. So others, are you able to solve this one? Here's a question if you need to see it again.
Sir, if you want to write, then I am saying you can write.
Okay, it's fine. Don't worry about it. Okay,
We
just
can
tell me what to
also
do.
switch statement, switch case,
Okay, switch.
switch of yes, sir, cart.
Okay, case.
Case 1 for economy
Okay,
and case 2 for a standard and case 3 for luxury.
okay, case 3 for luxury, and then a default. Let's just put this as NA.
Yes, sir.
So print F NA. Okay, so what do we need to do in case 1, the economy car?
Yes, sir. Number of days. Simply multiply number of days with a number total cost per day for rental cost.
So I can just do this. Sorry, what? Printf percentage d,
D.
and over here what do I have to put?
Card.
Are you sure it's car?
Number of days. The number of days.
Days into
Into. Take minutes. 500.
500, correct. And similar only we have to do.
And similarly, we have to also write the code for case to case series.
Yeah.
700 and 1000. Yes.
Right. So will this work?
Sir,
Actually,
there
we
is
have to put a break between the cases.
yes, sir. We have to give
Good.
break. Otherwise, all the statements will be executed.
Yes, sir.
Good.
Simultaneously.
That was what I was waiting for. Okay, and now will it work?
Sir, actually, it does not required for break in last time because it is also a default bit.
I mean, in case 3 you need a break, otherwise it will print NA also after printing this one.
Yes, sir. Sir,
Okay,
both the statements will be executed if we don't give that break in third one.
Correct. So now can you just tell me if this code will work?
Please give me 1 minute to check. I think this will work.
It does
Sir,
not work.
simply take inputs from
Exactly.
the user.
Exactly. So we need to scan F, %D, %D, comma, and car, and days.
Days.
Right? So now if we run this, okay. So now if we run this, and I put 1 and 5 over here, 2500. That is correct.
Yes, sir.
If I put 3 to 2000. So yeah, this is working. And if I were to put like, let's say 5 to NA directly. So yeah, this is working.
Yes, sir.
So this is just a simple code, but this is basically like the level that they asked in the mock. So
Yes, sir.
very simple questions. You don't have to worry about it. And in the OPP, you just have to keep your head cool, and it's mainly like math that is the issue. So if you're good at maths and you can translate the formula into code, you are golden.
Sir, we can use any method in the OPP solution now.
Yeah.
Oh.
Any method works. So yeah, that's this one. Normally it is like you'd have to make a calculate rental cost function, and it will essentially call the function over here. You will have to write it over here, like in calc rental func. What is that one? Okay, calc rental cost, and over here you'll have int a, like int car, comma int day, and then you'd have some code over here. But yeah, this is essentially like what you'd have to do if you were going to write a function. You'll see this in week 5. Yeah. So this is mainly like what we are expecting with the time mocks and OPP. Are you guys having time mocks this term? Do you guys have like timed mocks? Like from the like
The time
course, I
assignment.
cannot see any like timed mock things.
No, sir.
Okay, so I guess they might have removed it. But yeah, just uh, if you want to practice well, just uh, take like a 2 hour timer and try to solve as many C programming problems that you can in that time. That is like the best way to practice for the OPPE.
Yes, sir.
And yeah, like the other two questions, since they are like from week 5 and we have not touched week 5 yet, you can just do that on your own. We have like 20 minutes left, so I guess we'll just finish up the week 4. So simple interest. Okay, I guess I've already showed that one. We question 5, I guess we have not done yet. Yeah. So tell me what we can do. We want to find if two integers are co-prime or not. Okay, you can speak. It's like it's not really all that tough of a problem.
Can I? Yes, sir.
Yeah.
Can I tell the logics?
Yeah, go ahead.
Uh, yes, sir. For checking the co-prime number, we have to suppose we take our inputs from the users, and
Hmm.
it will check. Suppose we take our inputs that is 20, and it will divide by every number that is from 1 to 20, and it
Okay.
should be only divisible by 1, not other than.
Okay, so let's say that I have a number 21 and 20. So normally both of those should be like indivisible, right? Like
Yes,
those would be co-prime.
uh, yes, sir.
So
Co-prime.
what will happen? Like since 20 is smaller than 21, you are saying that we should check if it is divisible by every number until 21, right?
Yes, sir.
So can you tell me if 21 is divisible by 3?
So if 21 is divisible by 7, but there is no common 7 as well as 3.
Right.
But
So we
in
need some other way to measure, right? Since if we just go from 0 to the smaller
find
number,
also the commons between them, and it should be only 1. The common between two numbers should be only 1, no other than.
I understand that's the like definition of co-prime, but
Uh,
we need the code, right? We need to implement the math into the code.
okay, sir.
Keep thinking like you're on the right path.
Sir, we can use a for loop.
Um, yeah, you can use for loop. You need to use for loop, I think so, in this one.
Yes, sir, for check every.
Yeah. I hope you guys are not getting too bored in this class.
Yes,
No, sir.
No, sir.
it's an interesting
Yeah.
class.
Okay. If you guys have any feedback, I'd love to hear it. Okay.
Okay, sir, okay.
So, any like insight on what to do? Okay, so I'll give a hint. A common factor means that that factor divides both numbers, right?
Yes, sir.
Yeah, so if a factor, if a number is a factor for only one of the numbers, then the two numbers can still be co-prime, right?
Oh, yes, sir.
Yeah, so that's the hint.
Uh, yeah, I got it.
Okay, so you guys got any idea?
Sir, I have an idea, but we can't tell you directly into the code.
It's okay. You can tell the logic behind it.
Uh, Sir, my logic is still same that I will divide for every number until we reach
Okay,
the
so
extreme
I'll just do
position.
it like this. For int I equals 0, or I guess this should be 1.
Yeah,
I less than b I plus plus. So this is like the basic for loop. And now we have like if a is a modulo I equals 0, right?
yes, sir.
If it's that, then
This is not coprime.
yeah. So for keeping track of coprime, I'm just making another function over here. So 1 coprime equals 0 break, right? So if this is and then we can just, so if this is like divisible by any number at this point, it will set the coprime to 0, it will break. And after that, if coprime then printf coprime else printf not coprime. Okay, so this is like what you were suggesting, right? Sorry, let me just see. Yeah, so that was what you were suggesting, right? Yeah, so there's a very simple way to fix this one. Can you see it? Uh, it's okay if you guys are having a bit of trouble seeing it. So what is this doing? Can anyone explain me?
Uh, yes, sir. As we get the inputs from the user, it is stored in a variable, and it is a modulo by I,
Okay,
which is
and
initializes is equal to 1, and if it divides a completely divides, then coprime 0. It means it is not a coprime number.
okay. So it is only checking for A, right? So let's say that A is 20 and B is, let's say, 9.
Yes, sir.
In that case also, like, it will go to 2, right, at some point.
Yes, sir.
So if it goes to 2, in that case, like, it will 20 is divisible by 2, right? So it will break it and say that the two numbers are not co-prime, when
Oh,
20
okay,
and
okay.
9 are
I
co-prime,
got it. Yes, sir. Yes, sir.
right? So can you just tell me how I can fix this?
Uh, modulo 1.
Okay, I want someone other than Ravikant to answer this one. Like, Ravikant, you've been very like very active in the session today, so thank you for that. But I want someone else to be, answering this one.
So,
Yeah, Krishna, you want to say?
so I think we should also check for B to modulo I equals 0 or not.
Very good. So that's actually the solution for this one. So essentially, what we want for co-primes is that they have no common factor other than 1, right?
Yes, sir. When the
So
cases are when the combined two cases will be okay, then it's print that it is not coprime. Yeah.
right.
I got it.
So yeah, that's the solution. So we can just test run this to make sure that it works. If it does not work, then we'll just do some debugging and it will work. Yeah, but it works first try, like a charm. So good job, guys. You managed to solve this one. We still have enough time for one more problem.
So
Uh,
actually, I have a doubt, sir.
yeah, go ahead. Yeah.
So, in the last one, if condition co-prime, I didn't get that point. Can you please explain it?
Okay, so see, I initiated the coprime value as 1, right?
Yes, sir.
So what will happen if it goes through all the cases and this condition does not trigger? What will happen?
It keeps the value 1.
Right? And what happens if this condition is triggered?
Co-prime is equal to 0.
Right? So we have 0 and we have 1. So I can just directly put this in here, right? Because C program treats 0 and 1 like Boolean false and true,
Okay, so okay, I
respectively.
got it. I got it. I got it.
Yeah, so directly I just did.
Okay, so thank you.
Okay, anyone else has any doubts in this one?
No, sir. It's
Okay.
clear.
Okay, so do you guys want to do this one like PPS 7, or should I answer like some general doubts?
So I have a problem in graded programming assignment. So can I just say it? Yeah.
Is it week 3 or week 4? Because week 4 I cannot really reveal anything about them. Week 3 I can.
So actually, this is in week 4.
Yeah,
Last question, I have did the code correctly, but when I test the run code and it not correct.
I mean, unfortunately, I cannot help you out in that case since we are not allowed to discuss the graded assignment uh,
Yes, sir. It
code
is
before the
limited.
deadline.
So actually, what problem does is when I write the code and compile and run the code in another compiler like VS Code with GCC compiler, it
Hmm.
runs very well. But when I test the code in this website, it shows error.
Is that so? I mean, see, like there are slight differences between GCC and the compiler used on the website. Uh, but most of the time, if uh, if the code is not working on one of the two, then it's likely an issue of compatibility and not exactly like you'll have to just remodel the code or something like that. I'm
Okay.
telling remodel, but basically you have to rewrite some part of the code because it like the core compiler on the website, it works pretty fine, like 97% of the time.
Okay, sir.
And for the rest 3% of the cases, you can always mail to support. um, okay, so I guess like we can just do like a general doubts part now, since uh, the yeah, since this is really just way too simple and not really worth doing anymore after we have seen the others. So yeah, just let's just do quick general doubts part here.
So in OPP exam, what is the user interface exam for?
It's basically the same as your portal only.
Actually, sir, it is given in a SCT test.
Yeah, so you guys have had your SCT test, right?
Yes, sir, I have done.
Yeah, so for those who have not done, do it as soon as possible. But yeah, the interface is really similar to your portal only. Just that
Yes,
you'll have to share your screen and you'll have to enable the webcam.
yes, sir. It is similar to that the OPP exam.
Yeah. So uh, yeah, the UI and everything, it's really familiar, so you don't have to worry about that. Just make sure not to, like, once sharing the screen, there's that little like uh, Chrome is sharing the window or anything like that pop-up comes up, right? So don't close that one. If you close, then it will count that as a tab change.
Okay, sir.
Yeah, so other than that, it will be completely fine. You don't have to worry about it. Okay. Anyone else?
Sir, I think there are two OPPs have been done in this term for C programming.
Yeah, generally there are two OPPs in a term. Uh, so yeah, the first OPP, the syllabus is generally from like week 1 to 6, but if there's no like programming assignment, then week 3 to 6. The second one is like week 6 to 9 or 10. Like it's a
Okay.
lot smaller of a this syllabus, but it's a lot tougher.
Yes, sir. Okay. Okay.
Yeah, because in C programming you'll have to learn about pointers. You'll have to learn about structs and this file handling. But given enough time, I'm sure that you guys will pull through.
Okay. Sir, one more thing. GDB assignment has been already completed. Uh, could you please update more questions in that terminal?
Which graded assignment are you doing?
No, no, GDB compiler.
ZDB compiler.
Yes, sir. It's given some assignments, but I have completed, so I want more questions.
Okay, so I mean, see, if you want more questions, then there's always like a, lead code and stuff like that. But yeah, we are trying to provide more questions. Like this time also, we have provided way more GRPAs and PPAs than what we had provided in previous terms. So yeah,
Yes.
like we are trying to provide.
Okay, sir.
Okay, and I'll also try to find some more questions personally and bring them to you in the next practice session, which I believe is on Sunday.
Okay, sir.
Yeah, the next programming session is on Sunday, and on Wednesday we have the doubt clearing session.
Okay, sir.
Okay, looks like we are out of time, so I'll just stop the recording here.